Hello, welcome to the next in our series of physics videos. This one is on the wave nature of light, and the next series will be on the particle nature of light, and we'll hopefully see why we have separated them into two separate series of videos. But this one we're just going to do the introduction and then diffraction. Now, the duality of light. There is evidence for waves and there are evidence for a particle-like nature to light. And the evidence for waves are, let's just go through them. I think there's one more. Is that it? No, two more. Double slit interference. We'll commonly refer to that as Young's double slit experiment, but it's where you get interference, which is a wave property. Now, these are a list of all the things that light shows. Diffraction, that's a wave property. Refraction. Thin films. By thin films we mean why you're able to see rainbows on top of oil slicks, like multiple colours and things on top of oil slicks. That's slim films, thin films, but that's not part of our course, so we won't be looking at it in too much detail. Electromagnetic waves in the electromagnetic spectrum. Light sits into that. Polarization should be with a Z there, I think. And optical Doppler effect, which is what we use to work out whether stars and galaxies are moving away or towards us. Again, that's identical to sound Doppler effect in terms of the principles behind it, but it's also outside of our course. But these are all evidence for wave property for light. The evidence for a particle nature for light is things called black body radiation, the photoelectric effect, X-ray production, and Compton scattering. And we'll be doing that in the second series of videos relating to light as a particle. Alright, so just separate them out. So we'll be running through these ones in this series, and in the next series we'll do those ones. So predominantly for us, these are the things that we will look at in our physics course: diffraction, interference, refraction, polarization, and dispersion. The other things are not in this course, unfortunately. Can't fit everything in. So diffraction of light is exactly the same as diffraction of sound or water waves. It's the bending of waves as they pass through an aperture or around the edge of an object, and light does that as well. And so one way you can do this is you can see this for yourself. Even though light has a very small wavelength, we can cause it to diffract. And what you do is you get your fingers and you bring them very close together, hold them in front of your eye and up to some light, and if you're really careful, without bringing them perfectly together but very close together, you can see a black sort of thing merge between the two fingers even though they're not touching. And if you jiggle that around a little bit, you can actually start to see bands in that, and that's an evidence of diffraction. Fringes, these black lines appear. So have a go at that. I don't know if it works if I do it like that. What do you reckon? Probably all just gone blurry. Anyway, have a go at that. This is an example of diffraction. So here we see someone sitting in a plane. The sun's on the other side of the plane. And if we were really lucky, we could see a little shadow there of the plane, and around here you see a rainbow, a circular rainbow effect, and that's diffraction caused by the edge of the plane and the light. And so anywhere where you see rainbow effects from light, it's pretty much an example of diffraction. And so examples are rainbows most commonly, but also when you look on the back of a CD or a Blu-ray disc, you can get lots of colours. Excuse me. And any other situation like that where you get colours, it's a case of diffraction. So in the next video, we're going to look at Young's double slit experiment. See ya.